The module that we are going to cover is exception handling. So why don't I first open up this is following the textbook, as you can see here. So I am going to quick guide you so that you can understand. This is a motivating example. So why do we need exception handlings? First of all, if you think of the division process, division calculations, I hope you all know the division is impossible if divisor is 0. Division is this, for example, if we have dividend 12 and divisor 3, then our question is, how many 3 can fit in 12? So 3 can be fit in 12 4 times, right? 3, 3, 3, 3. Then it'll be 12. So that is this. But what if we say 12 divided by 0? How many zeros in 12? We cannot say anything, right? Maybe somebody may say, oh, there's unlimitedly many. Then maybe so. Or somebody says, oh, none, no zeros there. There could be many ambiguities involved in this division by 0 computation. So we need to avoid if there is any 0 divisor is applied. Okay, so in this code, x equals 23, y equals 3, y equals 0. And if you want to print this, remember this is a placeholder. This will be the first element of those, right? So whatever x, so here dot notation, and everything here that is a string dot format. So in this, the format function improves the display of whatever that we want to display using print statement. So this is a string dot format. Format is a function, therefore parameters. So we have 3 parameters, x, y, and x divided by y. So in the same order that we have here, the placeholder, 3 placeholders, which is curly brace. So curly brace divided by curly brace equals curly brace. So first, the curly braces can be, x will fit in the first, and then y will fit in the second placeholder, and the result of this division will fit in the third placeholder. Problem right now here is x divided by y. X divided by y. X divided by y, then y equals 0. So this is exactly the division by 0. As we looked at here in this example, then it is not possible. So that's the computation inability is also recognized by Python. So if we run it, then there is a error like this. Line 4, this is a 4th line, the modules. This is a statement. On this statement, there is an error, and this Python identified that error and says zero division error. This is the exception. Particularly, this is an exception. This exception says division by zero. So you tried pi division by zero. So that is the error. So Python cannot handle this unless you handle the exceptions on your codings. So look at this, coding the exception handling codings. Actually, it has try. So we first try, and then except. Try and except handlings. So if there is a this XY, the same code, we want to try this same code, and then this is try colon and except colon. In the except colon, we specify exceptions. You could use this exception more specifically, but exception is general. Exception accepts, there are a lot of exceptions predefined in Python. So you can simply use it. If you look at the textbook, let me point out if I can reach. Oops. Then on the textbook, there is an exception, the list of exceptions. Oh, wait a minute. Okay. Page 21, note 2.1. There's a table. List the standard exception. So this is predefined exceptions listed there. Among those exceptions, there is a hierarchy. So exceptions are hierarchically defined. Top, there is a base exception, so-called base exceptions. All the exceptions on that hierarchies, under that hierarchies are also base exception. This is a generalization of exception. For example, system exit exception is a base exception as well. So if you want to generalize it, you can generalize it generally based exception. Or more specifically, if it is coding related exception, then that is simply exception. This division by zero or zero division error, that could be somewhere maybe, it's not listed all, right? I think it is arithmetic error, which is, I'm not sure if you can see it. Right, on page 22, note 2.2, in the hierarchy, there is a, on the left side of that hierarchies, the bottom, there is a zero division error. So zero division error is in this the simplified hierarchies has a the parent node in this case, arithmetic error. So what that means is that zero division error is an arithmetic error, which is a so-called subclass or sub-exception error class of exception, which is subclass of a base exception. From the top, there's a base exception. Underneath, there is a child exception. So simply, exception is on the right end of the first level, second layer of that tree. Under that exception, there are multiple of the child nodes available. Among those, there is an arithmetic error exception, which is the second from the left. And then arithmetic error has three child exception errors. So third one is a zero division error. So this is hierarchically organized, okay? Because this zero division error is an exception, so we could generalize the exception in place like this. After except, we can put here generalizations of this exception, or we can put here arithmetic error, or more specifically, we can use zero division error. As is, we can simplify this exception like E. And then in this, if this exception occurs, this is an exception case, which means when a given divisor is a zero, then rather than try to compute, if we try to compute, because the error takes place, instead we go to except, and then we do whatever we say under this except block. This is under except block, we put here print statements. Rather than quitting, here there's a quitting, right? On except is handled. So this exception we put this. Okay, this is simply the placeholder. Similarly, this is a string, and the beginning of the string, this is the end of the string. Inside everything is a string, and then this E stands for exception. This E can be fed into this placeholder, and then we want to make sure this is the beginning of a string, this is the ending of the string. Whatever we want to say, quote, double quote inside, if you want to say it, then we need to use this escape character. Okay, this is escape character. What that means is that when we have this is the beginning of the string. When we encounter next to double quote, because double quote start to double quote and then end double quotes, they are well matched. Therefore, this Python may be able to say, hey, this is from here to here, that is a one string. And after that, if we have this curly brace, then there is another error. So that is not what we want. What we want here is from here to there, there is a one long string, and inside we want to have a quote, real quote. Okay, not the indicator quote, but the real literal quote that I want to say. If you want to say literal quote, then you need to escape. So parsing this print statement, the parameter in the print statements, then first here, double quote, then parser now scan until next quote. And when it comes to next quote, then parser say, hey, from there to this end quote, everything is a string, therefore don't touch it. Simply print it, right? We do not want the parser to be confused by this double quote. Rather, we say, hey, you escaped this double quote. And therefore, this double quote is not the indicator for string, but this is a literal double quote. That is the escape from this parsing. Therefore, parser knows first quote and waiting for the second quote. Then when it comes to here, there's a lot of spaces, right? And here it says, hey, you escaped the very next ones. And then this is a placeholder. And there is another double quote. Hey, you escaped this. And then keep going. And when it comes to this double quote, hey, this is the end double quote. So beginning and ending the double quote. So whatever inside that is string. After the string, we have dot notation and then format. That's what this guy wants to do to avoid these errors. Error may be displayed. So if we want to avoid it, then we need to handle that exception. Let's practice this. Okay. Okay. Yeah. I want to copy and paste this. And then if I execute it, then there is an error, right? So to avoid that, what we need to do is we need to do try, and everything should be under that try block. After this try block, then we need to do except. If we know this error, and then we can simply use this. If you do not know, then you can say except, exception. And as E, and then you can print that. Copy and paste here. All right. So when I type this, when I execute that, then very nicely it says rather than quitting on exception, division by 0 is handled. Okay, this error, this is an error that is handled. If you want to do rather than this exception is a very high generalized exception, but you can do instead the 0 division, 0 division exception. You can do that. Still, it works, right? This is the very specific errors. You can do also in the middle, the very next generalized exception, arithmetic error. This is also fine. If you execute, it's fine. Okay. Any exceptions along that hierarchical path, you can use it. You can use a generalized exception. Okay. This is more critical if we say so user input. If this comes to user input or data comes from external source. Let's say it comes from sensor reading data, or it comes from the web server, or it comes from any RESTful servers. So JSON data maybe comes into your system. Whatever it comes, we need to handle the exceptions. One of those is, say, the user interaction. So if we say, give me 2 numbers for division. And then you can say 2 numbers equal. Remember that the numbers typed from the keyboard, it's not really number, it is a character. So you need to change that number to, change the character to number. Although very nicely, the user may give 2 numbers, but numbers hit from the keyboard keystroke is not really number, that is a character number. It looks like number, but internally the coding treat it as a character. All right. So 2 numbers comes here, then we need to split 2 numbers, right? Let's say 2 numbers, or simply 2 numbers. Okay, so numbers equals 2 numbers dot split, open and close. So if you ask user to enter 2 numbers with the quote inside, delimiter quote, then you need to split by the quote. But in this case, just white space. And those 2 numbers, the first number, I would say integer, int of numbers is 0. This is the first number. And second number is int numbers and 1. This is the second number. And the first number, second number is handled in this case. So if you do this, then give me 2 numbers so that we can give 12 and 3, then 12 divided by 3 equals 4.0, right? So that looks okay, right? But what if we do 12 divided by 0? Then we can say, hey, rather than quitting, an exception division by 0 is handled, right? Because this is 0. So this is basically that exception can be handled. So usually we need to do, as you can see here, lots of exceptions, maybe oops, why? I want to select Oh, why? I want to select. Okay. All right. So I have a pen. Input needs to be validated, whether it is correct or wrong. So that we need to check. It's not only division by zero or zero division error. There could be a lot of different errors. Some of the typical errors are predefined, so we simply use it. If some errors not really the Python related errors, but business related errors, or network related errors, or cybersecurity related errors, the errors not defined by the Python, but could be handled by on application professionals, then we need to define the exception. We need to define exception. So our exception should be under that exception hierarchies. When we define exception, that exception should be in that hierarchy. Hierarchy already defined by the Python. So that is the next topic. It will be next week. But this week, today, we look at only something provided. So input data needs to be validated. Type should be checked. And if we consider all the cases, then it should be, the cases are fully covered. So coverage needs to be also verified. And if not covered well, then we need to handle it. Okay. Input validation, also known as data validation, and testing any inputs to prevent improperly formed data. Why? A lot of issues, right? As we looked at in the motivating examples, there are a lot of others. If it is not validated, so if not proper formed data comes in, then that will be the threat. So some injection attack, memory leakage attack, or compromised systems, and etc., etc. Therefore, we have to handle it. So this is kind of some of the data. Here, enter your age, then user may enter some number, then we can reply back to, you are, for example, 19 years old. But so it keep going, right? We keep going and going and going. And this is similar to this. The following code is age of users. Okay. Enter your age and try that age. If there is no, once we know the age, then we originally more input. This is true. So we switch back to false. So next time when we reply this, then it'll stop. This while loop will stop. This exception value errors. If it is not in, your age should be integer. But if somebody says some others, then we need to say that is not true, so that we can print that. So value errors. You can practice this if you want, but once more, I am going to cover this for example, some of the data not once the data comes, I think it is. Oops, what happens? Maybe this. Or enter your age, then we can say 12, then it says you are 12 years old. But if we say the age is you, then it says invalid literal for int with the base 10. So that is not the case. So we until we get some data that can be converted into integer. When it comes to integer, then it changes to false. So this while loop will terminate. If I put anything like this, then it keep asking. But when I say 77, then it says you are 77 years old. This is what that calls the code, right? If to avoid non-integer input, to avoid the non-integer input, this exception is handled. Okay. This is two. So this type of errors occurs in many cases. How do you know this is a value error? It could be known, for example, we first start this is invalid ones. So if we run the first one, and if we put there some numbers like this, then it says some of the errors, this guy already know that is a value error. So we use that value error here. Okay. So if you look at the error hierarchy, exception hierarchies on page 21, then you will be able to see where that value error in place. But that is not specifically here. That maybe probably in OS error somewhere there. Okay. You can find out. Or I'll show you here Python. I say exception hierarchies, then we have that hierarchy in this library. Okay, here's some. So that is a value error. It's not this OS error, but maybe let's see. Value error. Oh, value error could be type error, or could be Unicode error. Well, there's a value error, specifically value error, and the value error here. Value error is directly under exception. Okay, so parent error of value error is exception. That's value error. Okay. So instead of this, you can say exception. That's fine too, right? Oops. And you can run. Anyway, it is. There's a send error like that. And then you can say, it didn't change it. Oh, this guy does not know, right? Yeah, in this particular cases. Does not know when it comes to here, it should be changed to false. Let me stop this. Shall interrupt and shall restart. Yeah. So this is something, because this is vague, we chose generalized exceptions. So to interrupt. And then we start. Once we have here value error, if we say exception in general, then this guy does not know which ones explicitly this guy wants, therefore it keep a while loop. But if we say here value error explicitly, then this guy says, hey, we satisfied. Oh, still not. I think we need to. This guy already understands that internally because of this. So best way here is that if we save this, save this, and restart, then it will disappear. Okay. Oops. Okay. Well, anyway, let's keep going. So another example. Exceptions for one single try. For one single try, we could have multiple except. That's fine. Okay. So first handles, and in this case, we need to raise the exception. In this case, if this is the case, then we will raise the exception. If y equals to 0, then raise the exception, so that particular error will be raised. Okay, like this. So more specifically. Back to our example. Therefore, if we want to handle it properly, then you need to say here try this. Then here, if user number here's what you need to do. Is instance of or is integer. We can say like this. Is instance if this is if this if the user number this is we assume this is a user number because we ask a user to enter age, but user may enter something else. If that is a string number is also string, right? So not integer. Is numeric, maybe is numeric method. The reason for that here, I'll explain this. Say user number equals, we type this, okay? User number, copy, paste, and enter, then say 44. Then type of user number, that's a string, right? That is also string. Of course, that is string. Although we assume that is 44, that is also string, and this obviously that is a string. Any number that the user enter from the keyboard, then that is a string. But this can be changed to number, right? Changed to integer if we have this int function. By itself, as is there also the string. So back here, in this case, the user input, user number is that. So user number dot is numeric, then it is not numeric, right? Of course, it is not numeric. But what if here, if you just says 22, and then usual number is this is string 22. Remember that here? String 22. If we say is numeric, yes, it is numeric, right? So we can use it. If this is both user entered keyboard entered the value, this and this, all the type itself is string. But if we say is numeric, this method tells us this method works to verify whether this can be converted to a number. This cannot, right? But this number, port 22, can be converted to a number because that is actually a number that your user wants to enter. So it returns true. So this is the thing that we want to use. So if this is numeric, if it is a numeric, then we can simply do this and change that. Else, then we can say raise, and then we can say value error, okay? And this should work. This is more, I mean, this is better, right? So if we else should be inside here. If and else, this should be inside. We need to execute it and user enter. Then we can say 233. Oh, because of this, we have here, yeah, MOO. Interrupt, restart, only because of that. So if we have 23, then of course it is. If that is something else, then it goes something and it goes, then that ends. But this is better. Let's copy this. And this is number 1. This is number 2. And originally we didn't use this, right? Originally we didn't use this. We simply like this. And that should. So if we say because of the type we bring here, and then we say this, then it'll stop. If we do that and whatever, it stops. Same thing here comes. Then with this, yeah. In this case, we can do a little more. We can handle a little more, even if that is a numeric. And if we say, if age is less than 125 and greater than 0 greater than or equal to 0, then we can change it to false. Other than that, we can say we can still raise. Later, we can say we can define some other error, user-defined error, but today we don't do defined error. So we simply use a value error here, and the same value error here. If it is the case, then we can say this should be also can be improved. We can change this. We can do that only here. And if it is the else case, then we can say your number is valid age. And in this case, simply there are error messages. So this is more I mean, better ways that we can handle. This is improvement from here, right? We first to check if that is a numeric. If it is a numeric, then we convert that number to the age. And now we want to check if that is a real, reasonable, legal human age. Valid. Human age. If it is out beyond this, then it is not valid human age. Then we can raise up these exceptions. Okay. Let's try. For example, 345. Then it says your number 345 is invalid human age. Enter your age. Then if we say some, then didn't say here, but we could do something. And then 12 here, then that is human age. Here also you can say print simply not a numeric input. Try again. We can guide that way. Okay. So once more here, your age 999. Your number 99 invalid human age, not a numeric input. Try again. Which is not good. So we need to improve this. Rather than that, we can say not a valid age, simply. Okay. And if we say 222, then your number 222 is invalid human age, not a valid age. So this is not true, then it goes here else. Then print this. Your number is invalid human age, and the raise value error. So it goes to exception. So when it comes exception, then print not a valid age. Try again. So go back here, while loop. This while loop runs as far as more input is true. This while loop terminates when that more input becomes false when it comes to here. So when it comes to this legal age, human age, then it'll stop. So come here, if we say 34 ABC, of course that is not valid age, and only 23, then it'll be the age. All right. Okay, what else can we do? This can be done in dictionary as well. Key errors. Let's say this is the dictionary, and data set key give user says do something, do something is that function. Okay, so function call here, do something, which is this function, by sending B. So when it comes to this B, then here is, we say a data key, that is a key. B comes here. Then the value of key is B, so that we can return this value, the list 9 and 11, right? But what if we say the key that doesn't exist? We simply call do something with the parameter F. So when F comes here, try to find out if there is an F by solving this. But there is no F, then it is an error, right? So we have this key error, F. So we need to handle it. Okay, this is the end. Then this is an example. If you go to here, the textbook, example 2.7, let me point out, and then we'll finish up. 2.27, we can handle it. So error message is the appropriate error. So that can be handled. Yeah. So this, in the dictionary, we could have this kind of exception occurs. So how can we handle it? That is on exercise 2.6. And then it is handled, the key is on the page 27. So how this can be, how we can put here try an exception, try colon, and then you can put this there, and then there is a except. Okay, so this the key is appears on page 27. So this is what we have done today is, as you do code, particularly if your code wants to receive error from outside, maybe from the user, maybe from the internet, maybe from the sensor, maybe from anywhere, right? Then you need to sanitize the input data. How can you do that? If you don't handle the exceptions, then your code will stop, okay, abruptly, or your code may run continually. That type of error may occur. So we do here try and accept the block of code to be used. Exceptions that we considered today are the exceptions already defined and available for us to use. In the next week, we'll do what if the exceptions not enough? We need to develop our own exceptions. That's what we want to do next week. Particularly if you handle some of the codings for the cyber security, then the attacking symbols, any threatening symbols are, needs to be avoided or needs to be handled properly. Then you need to define the exceptions and then raise that exception, and exceptions needs to be handled. Again, exceptions needs to be defined, and then when that case occur, you have to raise the exception, and that exception needs to be properly handled. That's what we want to do. That's what we, a little bit of those handled today.